Okay guys, welcome back. We're continuing to talk about three-phase. This time we're going to talk about the delta configuration. So I've taken my same machine. Basically it's the same machine as this, okay guys, which has a phase voltage of 120 volts. But I've decided I'm going to connect it delta instead. And so the question is, if I've connected it this way and I measure across the phase, I get 120. What's going to happen if I measure across the lines, okay, any line to any other line? Well, if you take a look at it, guys, with three-phase, guys, the best thing to do is to look at one corner at a time, okay? So with this one here, because it's confusing otherwise, right, guys? So here we covered this up so that we could visually see that these two phases are in series causing this voltage to occur. Okay, and so we're going to do the same thing for this one here because otherwise it's confusing, okay? And we're just going to cover this up. Everything, that those wires aren't connected to, or at least for now, okay guys? So you'll notice that this thing is here. Now, if I take my voltmeter and I measure here, okay, from there to there, that's my phase voltage, 120 volts. Now I'm going to move over to here, and what's my voltage over there? Well, you can see that the line voltage is in parallel with that phase voltage there. And so the line voltage on this particular machine, because it's connected delta, is going to be 120 volts, okay? And if I were trying to figure out this line voltage, guys, I could cover up that. And if that guy's 120 volts, then that's going to be 120 volts, right? And if I wanted to go from line here to line there, these two lines, I could see that this is in parallel with it, and I can cover those ones up. Sorry, hard to see, right? But cover those up, and that 120 volts is going to be present across this guy right there. And so the formula for delta for E line, guys, is it's always going to be equal to E phase. And if I wanted to look at those as phasors, guys, I could do that. Let's do that for a second here. Let's get the red, black, blue going here for a second. Let's see if I can find my blue marker here. Let's take a look at this for a second. So here's my, kind of phasors here, okay? There's my one. And I've connected this other one like this, right, guys? And I've connected this other guy like this. All right, and so there's my three phasors. And, I'm connected off these corners here, right? So there you can see my 120 volt phase voltage right there. That red line is 120 volts long, okay? And from line to line there is also going to be 120 volts. But, guys, there's my line voltage, 120 volts from there to there, right, guys? Now, what about these other two phasors? All right, because they got to be doing something, right? Because I've got this thing's 120 volts, and so is that black one, all right? And so how do they affect it? Well, I'll show you guys because, and this is beautiful, okay, guys, because let me separate those for a second. I've got this guy right here, all right? And there's my 120 volts. And that's my E phase, right? And then I've got these two guys here, this one, 120 volts, and this one, 120 volts, okay? So that's those two guys. And the phasor sum of these two guys is going to be a line that goes from here up to here, okay? So this is the resultant of these two. And what I'm trying to show you here, guys, is this is 120 volts right there, okay? But these other two guys, their phasor sum is also 120 volts. And so when you have the wires coming off here, they're actually being fed from this 120 volts, which is this phasor right here, and the sum of these two, which is also a line that's at the same phase angle and at the same value as that. This green line and this red line are exactly the same, and they're actually sitting here right on top of each other, okay, guys? So yes, those two do play a part, but the phasor sum of those two is a line that is equal to 120 volts at that phase angle. And it doesn't matter which ones I choose, okay? If I choose this one, so let's say I'm, coming off of here and trying to measure this, I'd be seeing this 120 volts here, and then I would have the phasor sum of those two, which would also be a line that's right here, all right? And if I chose that one to that one, I'd be looking at that 120 volts right there, but in parallel with that would be the phasor sum of those two, which would be, 120 volts right there, okay? And don't worry about the arrows too much, okay? Because it's confusing, all right, guys? So, what do you really need to know, guys? Okay? With a delta connected system, the line voltage is equal to the phase voltage. All right, guys? That's what you really have to know about that. I'm just showing you what's going on here with all these crazy phasors. But let's say I had a 10 amp load here, okay? So my 3 lines here, that's I line, right? All right. So the question is, if I have some load out here that's drawing 10 amps, my line current would be 10 amps there. The question is, what is my phase current? And the best way to actually look at that, is to block out most of this stuff again, right? We're going to look at one corner of our 3-phase at a time so that we're not, our minds don't explode, basically. All right, guys. So we've got 10 amps flowing here, guys. And if you look at this here, that means that 10 amps is being fed by 2 of these phases. All right. And so some of that current is going to be coming from here, guys, feeding that 10 amps. And some of that current is going to be coming from here, feeding that 10 amps. Now, it's not going to be 5 each because these guys are out of phase. But what it's going to look like is this, guys. I'm going to have a certain amount of current here. This is going to be I phase, okay? And to it, I'm going to add a certain amount of current right here. That's the other phase, okay? And the sum of the two is going to be I line, okay, guys, for this delta system. And we already know that the I line is 10 amps, all right? And so, I could figure out, I could apply a whole bunch of trig and try to figure it all out, guys, but you can see that this diagram is the same as this diagram here. This is the voltage diagram for a Y-connected system here. This is the current diagram for a delta connected circuit. I mean, this is 120 degrees, that's 60 degrees, Trust me when I tell you guys that I line for a delta system is going to be I phase times √3, all right? And so that is going to work 100% of the time if you're trying to calculate the phase current and the line current, or if you're trying to calculate the line current and the phase current, guys. And so just for fun, for this one here, we'll calculate the phase current. In this particular one, I phase, guys, is going to be I line divided by √3. I'm just transposing this, okay, guys? And so it is 10 over √3. Let's calculate that. 10 divided by √3 equals 5.77 amps. Okay, guys? And that means that if I clamped on right here, I get 10 amps. If I clamp onto the phase right here, guys, I get 5.77 amps. I clamp onto this phase right here, I get 5.77 amps. And same with that one, right, guys? 5.77 amps. That's all the phase current. All right, guys? And those guys are the line currents, I phase. So let's summarize real fast here, because I want to have all these formulas in one place. All right, guys, let's write them down right here. So for Y, this is always going to be true for the rest of the intake. All right, guys, and it's just true in general. Okay, guys, the formulas for Y, E line is equal to E phase, times root 3. Okay, guys? I line is equal to I phase. All right? Delta. Okay? The formula for delta, E line, is equal to E phase. Always true. Okay? I line is equal to I phase times root 3. Those 4 formulas, guys, those are the ones, all right? And we're just going to keep applying them from now on. So you might as well get used to those and get them into your brain, all right, guys? And come back for the next video where I kind of summarize all this stuff and try to make it a little bit easier and less confusing, okay, guys? So